Let's look at solving integrated rate law problems. We have two types. The first type, marked in green, are first-order problems. The green equations are the same equations, they've just been rearranged. The second type are second-order reactions, which is shown by the yellow equation here. So the first thing we need to do when we read a problem is decide what type of equation we have. So we have the rate of disappearance of sucrose equals K times the concentration of sucrose. They have given us an exponent here of 1. So we know right off the bat that this is going to be a first-order reaction. So this is first order. So we're going to be using one of the green equations, whichever form is easiest to use. So what we're going to do is see what information we are provided. So the initial sucrose concentration, they give us that value, A0, is equal to 0.010 molar. Then we are given the concentration at time t of 0.0010 molar. And they also give us a value for K, and K equals 0.21 hours to the negative 1. We need to solve for T. So in my opinion, the easiest form to do that particular problem is using the second green equation. So we have ln, and we have 0.0010 divided by 0.010, and that is going to be equal to negative 0.21 times hours. When we solve for t, which is hours, our hours are going to be equal to 10.96. We only have two significant figures, so that is going to be 11 hours. So that's our first problem. Now, let's take a look at our second problem. Now we're looking for the decomposition of dinitrogen pentoxide, and we're told it's 6.93 times 10 to the negative third seconds negative 1, and we look at the exponent on this concentration here, and there is no exponent, which means it's a 1. So once again, we have a first-order reaction. So let's take a look at what we have. Right off the bat, we have K. This is our value for K right here. So we have that K is equal to 6.93 times 10 to the negative third seconds negative 1. We are told that T is equal to 150 seconds, but we don't have the final concentration. But we do have an initial concentration. So now, when I look at these values here, the easiest form, in my opinion, is to use the first form in green up here. So we're going to have ln A at time t minus ln 0.100 is going to equal negative 6.93 times 10 to the negative third, and that is 150 seconds. When we solve for ln of AT, it's going to be equal to negative 3.342. Now, in order to solve for A at time t, we're going to take E and raise it to the negative 3.342 power, and that equals A at time t, which is equal to 0.0353 molar.